Hey, let's practice some logarithms. I'm David. I'm going to be helping out my pre-calculus class, but really help out a lot of people doing this. So let's practice some logarithms. In previous discussions or videos, I've talked about the circle trick. It's just a mechanism to help me remember where the base and the exponent and everything goes. So I kind of circle around an equal sign. So if I was to evaluate these logs, let's circle trick 29 here. So number 29. 1/2 to the x. So I circle around and I say the base to the exponent on the other side is equal to the inside, 16. Now I need to figure out what x would be the exponent in this sense that would make that 1/2 convert to a 16. I could guess and check this, and I still do many of these times. I kind of sit here and I guess and play and check, and I can't say it enough. That's healthy. That's awesome. Play with it. That's great. Like for instance, a negative, I know flips fractions. If I have a negative exponent, that 1/2 goes to a 2/1. And I know to take to a 2, what exponent would get it to a 16? 2 squared, cubed is 8, 4. Yep, 4 would take it to 16. So that's an example of me just kind of playing and figuring it out, using my knowledge. I could use something called a common base trick. If I take the knowledge that I had there, figuring out the -4, and just apply it to each side of the equation. For instance, 1/2 to the x is a 2 to the -x, right? If you remember the rules of negatives, then the negative exponent flips it, and then it's 1/2 to the x, which is the same idea. Another way to look at that is you could say 1/2 is -2 to the -1, and we are asking what exponent takes it to 16. That's another way to look at it. The advantage here is, and just so you know, I'm going to multiply exponent to exponent. That's just one of those old rules. So this becomes 2 to the -x, same thing. And now I'm going to take the 16 and I want to think about it as 2 to something. Again, very much like I was playing. And it's 2 to the 4th. Look, if you have same bases, you can set the exponents equal. Again, if your base value is the same, we're in the base of 2 to something here, then you can just set the exponents equal to each other. -x equals 4. X equals -4. Isn't that cool? Neat little trick. It's called the common base trick. Let's try it for 34 here. 34. Log base √3 of 9. I'm going to circle trick. √3 to some x. √3 to some x is equal to 9. Again, I can remember what square roots are in exponent form and play and do things like that, right? But I could also use the common base trick. You might remember square roots are 1/2 exponent. And if I take that to a power, you multiply those exponents. So now I got 1/2 x. And I'm going to set this equal to 9, but I'm going to convert 9 to 3 squared. Look, common bases again. If our bases are the same, set these exponents equal to each other. Makes sense, right? 3 to something has got to be the same as, 3 to something and 3 to something. The somethings have to be the same. I hate it when I get so verbose with my math vocabulary. The somethings, I know. Solving. Looks like I need a 4. So what exponent? What's the evaluation of that? This is a 4 evaluation. Let's do one more. Let's do 35 here. I'm going to convert ln to what it really is, log e, so I can circle trick it, right? I want to know what this is equal to. e to the x is equal to e to the x is equal to e square root to the 1/2. Hey, the bases are already the same. I can just jump to the answer. So, if you have the same base, set the exponents equal to each other. Let's try something else here real quick. Let's play with some log graphs. I want to just practice some domain and ranges. So I just want to grab two of these, and do a domain and range. Cool. As a reminder, I want to remind you, negative outside the function, like that guy right there, that flips objects like parabolas. Remember parabolas? That flipped them down, right? That's called a horizontal flip. So if I was to look for this one, I'm looking for one that has a flip across the x-axis. As I try to remember, a negative on the function is like a negative on the y. So we flip over x. So I'm scanning and, ooh, is that one the flip of it? I think it is. So negative log base 3 of x, which, just so you know, the parent function's right here. Here's the parent function on it. That's a, if you look up, that's a. Okay. And this is flipped perfectly across the x-axis. Can you see the symmetry? I hope. Let's talk domain and range real quick. Domain. Looks like the x's are above 0. So I can say x's are an element of 0 to positive infinity. If you look at the range, it goes all the way up. And as slow as it may be, this arrow down here, that's still going down. So it has a feature of still going all the way up and all the way down with no asymptotes to block it. I'm going to say all reals. It's all reals. Cool? Just a little bit on graphing and domain and range. Here's a cool one, G. Look at G. Try to get this shift. What makes 0 is the shift. I think x is 1 would make 0. So I'm looking for an asymptote of x is 1. But there's a negative on x. I've learned a negative on x, you flip over y. And so 70 right here, this graph is a flip over y, and it's shifted 1 to the right. See the asymptote? There it is. This one is log 3 of 1 minus x. Domain and range. Domain, looking at it, comes from negative infinity, stops at 1. Domain, x element of. Y element of, same thing, all reals. Now let's take this information and let's just put it all together here. Let's just put it all together. Okay? I want to think about this problem right here. So when you do your homework, you want to write out the equation. You don't have to write out all the extra words, but give me the equation. If you can think of the graph, think of the graph. If it's a graph of just your parent graph shifted around, it's good to do that. Think of the graph. Answering the questions. What's the domain? Well, if I had the graph, I could look at it. But remember, domain for logs, thinking of the parent function, means we keep the inside of the log above 0. If we don't, it'll be a domain error on any calculations. So you can tell it's a two-stepper there, and you don't flip the sign around. Subtract 1, divide by 2. So it looks like we're going to say all the x's that are bigger than negative 1/2 up to infinity. And that's your domain. Okay? Before I do B, I want to talk about this graph for a second. Could I have just graphed it and got the domain? And would that be helpful? My answer to that is almost always yes. If you can think of the graph, if you can even Desmos it, I don't care. Do so. It can't do anything but help. So if I take the parent graph, I always kind of draw or visualize my parent graph, right? And I shift it left. What makes 0 there? Left 1/2. Negative 1/2 makes 0 there. Yeah. You should know that because I just did it a second ago. Look, it's over here. I know it had a different symbol, but it's the same thing. And down 2. Can't say it enough. Once you've learned how to do these shifts, pretty much all the future graphs in math and science, if they're in this nice form, it's that easy. Take the parent graph and shift it around. Sometimes flip it, right, with the negatives. So the asymptote's at -1/2. Okay, I had a dot at 1, an x-intercept at 1, but it moved 1/2 to the left and 2 down. There's that dot. There's that dot. So I'll just draw a quick little sketch. Looks like this somehow. There's my log graph. Okay, and there's that dot that I moved. It's now at 1/2. That's left 1/2 from 1. Okay, and down 2. So I got a key dot too. What is g of 40? That's just plug and chug stuff. So g of 40 is just plugging it in. Log 3, 2 times 40 plus 1. And then got to be careful here. That's an exponent. That's what I've been trying to reach you at. So we got to do all of this log 3 stuff first. And then whatever number comes out, I'm going to take away 2. Order of operations is huge here. So this becomes log base 3 of 81. 2 times 40 is 80 plus 1, 81. Minus 2. I usually put parentheses to really emphasize that minus 2 is not part of the log. So I don't care what the textbook does. I do it because it makes my brain see it cleaner. Okay, circle trick. 3 to something makes 81. 4. 4 minus 2 is 2. All right. So I just plugged and chugged an x value of 40 and got an output y value of 2. So that means somewhere, I need to move my picture, somewhere down here is a dot where we went 40 over and only 2 up. That's growing very slowly. Part C. What is g of x equal to 3? So that means we're going to take the equation and set it equal to 3 and find x. It's kind of like what makes 3? What makes 3? Okay, so my favorite question right now. How many steps to solve? Students get a little freaked out by it. Check it out though. You know the steps. Look what happened when you went forward. It's right here. Here's where the algebra hint is. Many students don't realize algebra's just working backwards from there. So the first thing I did was times 2 and then add 1. So you know what the last things I'm going to do are? Undo those. What was the last thing I did? Subtract 2? Well, guess what? My actions, I'm going to do this like a textbook does, or students in Europe do it this way. Okay, I'm going to show you what I'm doing. I'm going to add 2. I'm going to circle trick to get it out of log mode. And then I'm going to have to get rid of the 2x plus 1 part. Working backwards, subtract, divide. And I'll have my answer. Check it out. Check it out. Now that I see all the steps, the math becomes so much easier. Let's add 2. Okay. Added 2 to the left. Took away the minus 2 on this side, right? That's the same thing as adding 2. Circle trick. Don't forget to go across the equal sign. It's just over there this time. Don't forget to go back to the inside. Circle trick now gives me 3 to the 5th is equal to the inside, 2x plus 1. How many more steps? I already have it. And just so you know, 3 to the 5th is 3 to the 4th is 81. 243 is 3 to the 5th. So it looks like I need to subtract 1 and divide by 2. So let's see what that looks like. Subtract 1. 242 is equal to 2x. Divide by 2. X is 121. That means there's a dot even further out there. I go over 121 x's, and I'm only up 3 now. This is a slow growth graph. My name's David. I hope this has helped. Peace. By the way, part D there, set it equal to 0. do the same thing I did right here.